Hey, welcome to a video on relative extremas. So for each of the functions below, find its relative extrema using the test specified. Use the sign charts to help you. So there are two types of tests. The first one is the first derivative test and the second one is the second derivative test. So you might be wondering why the second derivative test is being used to find the relative extremas, because you oftentimes associate second derivatives with concavity, not extremas. But then second derivatives of second derivative tests are a little bit different. So second derivative tests are the ones that are being used to find relative extremas with first derivative test. Okay, with that being said, number one is y equals e to the x cosine 3x from 0 to 1, and then we're using the second derivative test for this one. Right, so first find y prime, which would be e to the x and then cosine 3x, right? And then plus negative 3 e to the x sine 3x, right? Okay, and then we're trying to find where this is equal to 0. So we can use our graphing calculator for this one. That one is going to be when x is equal to 0.107. Okay, so let's see the second derivative of this. So e to the x cosine 3x minus 3 e to the x sine 3x. So since we already have the usage of the calculator, we can try to calculate this using the calculator, like the derivative using the calculator. So we're going to do math 8, okay? So dy over dx, and then we're going to put in our y prime function. So e to the x cosine 3x plus or minus 3 e to the x sine 3x, right? Okay, and then when x is equal to 0.107. So using that, we get y prime is around negative 10.5556. Okay, so which is less than 0, right? So it's a negative number. So by the second derivative test, y or f of x has a relative maximum at 0.107. Okay, so writing that down, by the second derivative test, f of x has a relative max at 0.107, and let's try to plug this in. So e to the x and then cosine 3 times 0.107, which would be 1.056. Okay, so usually you would have to write a full conclusion or justification on the second derivative test. So you have to say, like, by the second derivative test, f of x has a relative maximum at whatever point, because at that point f prime x is equal to 0, and then f double prime x is negative. You have to write all that, but then since I'm writing like some short solutions for a lot of these problems, I'm not going to be writing a justification for each of those, but you should be, and you should be doing this on your exams as well. Just remember that. And then y equals ln x squared plus 1 in the second derivative test, right? So y prime is equal to 1 over x squared plus 1, right? And then 2x, which would be our chain rule. So define when this is 0 undefined, this is when x is equal to 0, right? Because 2x equals to 0, x equals 0. And then to find when it's undefined, we can say x squared plus 1 is equal to 0, but then x squared plus 1 is never equal to 0. So we only have one candidate, right? And then we're using the second derivative test again. So y double prime equals 2 times x squared plus 1, right? And then minus 2x times 2x, right? Okay, so we get 2 or all over x squared plus 1 squared. So 2x squared plus 2 minus 4x squared all over x squared plus 1 squared. That gives us negative 2x squared plus 2 all over x squared plus 1 to the power of 2, right? So let's see if y double prime is equal or is negative or positive at x equals 0. So y double prime 0 equals 2 all over 1. Oh, yeah, 2 all over 1, which means 2, right? So this is positive, so this means that we have a relative minimum here. Okay, by the second derivative test, f of x 0 and then 0, 0, right? Okay, and then yeah, and then moving on to number 3, we have y equals e to the negative x squared. Using the first derivative test, so y prime is equal to negative 2x times e to the x negative x squared, right? And when this is equal to 0, so we know that e to the negative, or this can be rewritten as negative 2x all over e to the x squared equals 0. We know that x equals to 0 is one of our candidates, and then to find when it's undefined, e to the negative x squared, e to the x squared has to be 0, but then it's never 0, right? So we only have one candidate again, which is x equals to 0, but then we're going to do something different here because it's first derivative test. So do a sign chart, and then it's 0, right? And then greater than 0, we can do like 1, right? So negative 2 times 1 all over e, that's negative, right? That's less than 0. So we're going to write negative right here, and then we also have like a negative number, right? Like negative 1, which is less than 0. We're going to put that in here. So negative 2 times negative 1 all over e. So that's like positive, right? So that means that we actually have a relative maximum at x equals to 0. I'm going to stop writing some paragraphs because I have a long way to go. But remember, you should be writing full paragraphs for these ones. Relative max at 0, 0, 1. Okay, sounds good. And then moving on to number 4. X squared, y equals root x squared plus 1, first derivative test. So y equals x squared plus 1 to the power of 1/2. Y prime equals 1/2 times x squared plus 1, negative 1/2 power, and then 2x, right? So this gives us, cancel out the 2's, we have x squared plus 1 square rooted, and then just x, right? And let's find out when this is equal to 0. And that is also when x is equal to 0. And that's the only candidate, right? Okay. Since we have a first derivative test, let's draw a sign chart. 0, and then let's plug in like 1, right? 1, if we plug in 1, we get positive. If we plug in negative 1, we get negative. So that means that we have a relative minimum at 0 and then 0, 1, right? Okay, just checking our work up until here. Okay, good. And then number 5 is y equals sine squared 4x and 0 to 1, and then second derivative test, right? So y prime is equal to 2 sine 4x times cosine 4x times 4. This is 8 sine 4x cosine 4x, right? Double chain rule, and let's just do our graphing calculator trick to find out when this is equal to 0. So one of them is going to be 0, and then the other one is going to be 393, and then the other one is going to be 0.785. Okay, so we have a lot of candidates. Let's try to plug this into y double prime. So y double prime, I would say if it gets to a point where it's a little bit too complicated to do a second derivative, you can use your calculator, but then you should still try to do it for like simple ones. I would say for number 5, it's it's relatively simple, the double prime, right? It's just product rule. So I recommend that you do a actual like calculation instead of using the calculator. So y double prime equals 8 times 4 cosine 4x squared plus negative sine negative 4 4x and then squared, right? So we get 8 times 4 cosine squared 4x minus 4 sine squared 4x. Okay, and then I'm just gonna plug this in to see if like it's gonna be 0 at certain points, or it's gonna be negative or positive at certain points. So as you know, cosine 0 is 0 times 4, and then so for x equals to 0, f double prime of f equals 0 is positive. Okay, and then f double prime 0.393 is negative. And then for 0.785, that is going to be positive. Okay, so I'm going to say f of x has relative minimums at 0, and then let's see, 0, 0, right? And 0.75, and okay, that would be quite a small number, so 2.537 times 10 to negative 6. Okay, and then we have relative maximum at, what is this, 0.393, and then and then 0.999.